The Chapter 4 review is the best thing you could study for the test. There'll never ever be a test question that just isn't like a review question. So I'll just jump into it and talk about things as I need to talk about them. Question 1a wants me to solve g of x equal to 0. That's real easy to do. I'm just going to take the g of x function and replace the right side of it with this g of x symbol. I'm going to get negative 5x plus 4 in place of the g of x symbol. And the rest of this question equal to 0 is going to stay there. I'm going to solve for x. I need to get the numbers on one side and the letters on the other to solve this. I don't solve by factoring because there's not an exponent like a square. I'm going to add 5x to both sides to get lots of positives as opposed to lots of negatives, and then divide both sides by 5. So my answer to 1a is going to be x equal to 4/5 because the 5s are going to cancel, and on the other side you have a 4/5. For part B, I'm going to replace the g of x symbol with negative 5x plus 4. As I go to do part B, I'm going to do negative 5x plus 4 is greater than 0. There's two ways to solve this, so let me do both ways. And you can decide which way you want to do. They both give the answer that's equal to each other. The way that most students would do is they would minus 4 from both sides, which would give you minus 5x is greater than negative 4, and then they would divide both sides by negative 5. If you divide by a negative to solve for x when there's a greater than or less than sign, you have to flip the direction of the inequality. Doing it this way, you'd get on the left side x, I'd flip the greater than to a less than, and on the right side the two negatives cancel and you get positive 4/5. So one answer to this problem that's completely correct is x is less than 4/5. The other answer that's equally correct would have the 4/5 on the left side and the x on the right side, and the open ends pointing towards the 4/5, the pointy ends pointing towards the x. This would also be a correct answer. And this is the answer that I'd probably get because I'd solve it using the second way. If you solved it this way and flipped the inequality appropriately, that's completely fine. The other way to solve this would have been to add 5x to both sides. That would give me 4 is greater than 5x. And then I divide both sides by 5. And because the number I'm dividing by is positive, I don't flip the inequality. You only flip an inequality if you're dividing by a negative to solve for x. This would give me 4/5 is greater than x, which is equal to that answer, just it has the letter and the number switched. For part C, I'm going to replace the f of x with 3x minus 12. I'm going to leave the equal sign. I'm going to replace the g of x with negative 5x plus 4. And I'm going to get the letters on one side, the numbers on the other. I shouldn't get this set equal to 0, specifically because there's no exponents with the letters. So I'm going to add 5x and add 12 to both sides. When I do this on the left side, the 3x and 5x gives me an 8x. The 12s cancel. Bring down the equal sign. On the right hand side, the 5x's cancel, and 4 plus 12 is 16. And then I'm going to divide both sides by 8. On the left hand side, I'm going to get an x. On the right hand side, I'm going to get a 2. The answer to part C is going to be x equal to 2. For D, and for the g of x symbol, I'm going to put negative 5x plus 4. I'm going to leave the less than sign, and then for the f of x symbol, I'm going to put 3x minus 12. You can solve this by getting the x on the right side or leaving the x on the left side. It's up to you. If you leave the x on the left side, you have to be careful. So I'll just do it that way, the way I have to be careful. So if I minus 3x and minus 4 from both sides, I'm going to have the x on the left side with a negative in front of it. Minus 5x minus 3x would give me a minus 8x on the left side. 4's cancel. Adding and subtracting, you don't flip a sign, so I'll leave it less than. 3x's cancel. On the right side, minus 12 minus 4 is minus 16. Now I'm going to divide both sides by negative 8. When I divide by a negative, I need to flip. And I'd get a completely okay answer of x is greater than 2. And that's the same as 2 is less than x, because in both of these, the open end's pointing towards the x, the pointy end's pointing towards the 2. The other way that I could have solved this is getting the x on the right-hand side. You don't have to solve it both ways, just whichever way seems easier to you, you should do. So I could have plus 5x and plus 12 from both sides. And solving it that way, on the left side I'd get 16, on the right side I'd get an 8x, and then when I divide, I won't flip. You only flip the sign when you're dividing by a negative. And in this way to solve the same problem, I wouldn't have to flip because the number in front of the x that I divided by is positive. And both of those answers have the same meaning. All right, done with problem 1. I'll just go through these to try to get it done in one part. So, school district number 2, a school district purchases 100 new televisions. The 100's a distractor, one for each classroom, for $50,000. After 8 years, the televisions will be worth $2,000 and they'll have to be replaced. Assume the relationship between the value of the televisions and the number of years in use is linear. Then it says create 2 points in the form age of the televisions and y equal the value of the televisions. So I'm going to have 2 points. Each of the y's is going to be the values of the televisions. The values that I see are 50,000 and 2,000. So I'm creating 2 points. The first point's going to have a y of 50,000. The second point's going to have a y of 2,000. Because the y's are supposed to be the value. The x is supposed to be the age. The first age, when I get the TVs, they're brand new or they're 0 years old. And then after 8 years, they're worth $2,000. So that's creating my 2 points that I need to create. And now I'm going to write a linear function. To write a linear function, I should probably use function notation as opposed to the letter y. This function is going to give the value of these TVs for the 8 years that I own them, or the district owns them. And to get a linear function, the first thing I need to do is get a slope. To get a slope, I'm going to use the equation y2 minus y1 over x2 minus x1. So I'm going to subtract the y2 minus y1. And then over x2 minus x1. This is going to come out to negative 48,000 over 8. And that's negative 6,000. Next, I'm going to use the y minus y1 equals m times x minus x1 formula. And in for the y1, I'm going to use 50,000. And in for the x1, I'm going to use 0. And in for the m, I'm going to use minus 6,000. So I'm going to go y minus 50,000 equals m, which is minus 6,000, times x minus 0. The right-hand side just simplifies to be minus 6,000x because x minus 0 is just x. And the left-hand side, I'm going to add 50,000 to it to get the y solved for. When I add 50,000 to both sides, the left side becomes a y, the right side becomes negative 6,000x plus 50,000. When I go to write an answer for part A, I'm supposed to write a linear function. So I'm going to replace the y with function notation. And then maybe I'll put t for the time and v for the value. But if you did f of x equals negative 6,000x plus 50,000, it's completely fine. So for part A of number 2, if your answer was f of x equals negative 6,000x plus 50,000, it fits the criteria perfectly. This is an equation of a line because the x has an exponent of 1, and it's in function notation. If you want it to be a little more fancy, you can say V of t, the value after t years, is negative 6,000 t plus 50,000. Both of these are perfectly correct answers for question 2a. For part B, to find the value after 6 years, I'm just going to plug in 6 to whatever equation I use for the variable that represents time. So to do part B, I'm going to do the value after 6 years, or do f of 6 equals negative 6,000 times 6 plus 50,000. That comes out to, I better not do that in my head, of 14,000. Negative 6,000 times 6 plus 50,000. And I get $14,000. So for my answer, I'm going to be real brief. I'm just going to write the number 14,000 with a dollar sign, and that's the value after 6 years. Don't need to write a sentence for that if I don't care to. All right, moving on to number 3. These are all word problems that we've seen early in the chapter with just different numbers. So a real estate office manages an apartment complex with 1,000 units. When the rent is $1,000 per month, all 1,000 units will be occupied. However, when the rent goes to $1,300 per month, only 900 units will be occupied. Assume the relationship between the monthly rent and the number of units occupied is linear, which means I can come up with an equation of a line to predict the number of units rented at various prices. Then it says create 2 points. X is the rental price, Y is the number of units rented. The first information I see $1,000 for the rental price gets 1,000 units rented. And then the second information, at a rental price of $1,300, 900 units will be occupied. So the 2 points I'm going to have, the X's are the price, the Y's are the number of units rented. There's my 2 points. Now I'm going to write an equation given for a line that gives the number of units rented, or the demand, Y, in terms of the price, P. It doesn't say write a function, so I don't need to use function notation. It kind of hints that it wants me for the price, which is the X, to use P. But I don't. If I used X and understood that the X represented price as opposed to P representing price, I'm fine. First thing I need to do is find the slope of the line. To find the slope, I'm going to do y2 minus y1, which is 900 minus 1,000, over x2 minus x1, which is 1,300 minus 1,000. This comes out to negative 100 over 300, and that's negative 1/3. Next, I'm going to use the y minus y1 equals m times x minus x1 formula. In for the x1, I'm going to plug 1,000. In for the y1, I'm going to plug 1,000. And in for the m, I'm going to plug negative 1/3. So I'm going to get y minus y1, which is y minus 1,000, equals m, which is negative 1/3, times x minus x1, which is going to be x minus 1,000. This is going to give me y minus 1,000 equals minus 1/3 x. And when I do minus 1/3 times 1,000, I do parentheses minus 1, if I turn my calculator on and do parentheses minus 1 divided by 3, close parentheses, times minus 1,000, and do math, enter, enter, I get plus 1,000 over 3. Now I'm going to add 1,000 to both sides to get the y isolated. I'm going to do that all in my calculator. So I'm going to get y equals minus 1/3 x plus, and then whatever 1,000 over 3 plus 1,000 is. So I'm going to go 1,000 over 3 plus 1,000, and then math, enter, enter, so it's plus 4,000 over 3. I was kind of hinted that the demand could stay y. The number of units rented is the demand. It can stay y. But the x's, which represent the price, should turn into a p. So when I go to write my answer for 3a, I'm going to say y equals negative 1/3 p plus 4,000 over 3. We could certainly use x instead of p for the price. All right, now I'm going to use the equation to answer some questions. Part B, use the equation to predict the number of units occupied when the price is 1,200. So I'm going to plug 1,200 in for P and get the number of units. So I'm going to get Y equals negative 1/3 times 1,200 plus 4,000 over 3. And then it says round to the nearest unit if rented, if needed, because I'm going to get a decimal answer here. So I'm going to go Y equals parentheses negative 1 divided by 3 times 1,200 plus 4,000 over 3. And I get 933.33. I'm going to round that to 933 and not give a fraction answer because you can't rent 1/3 of a unit. So my answer for part B is just going to be 933 units will be rented. When I go on to part C, it says what price will cause 800 units to be occupied. The 800 units is a Y because the Y is the number of units. I'm solving for P. So I'm going to go into this equation and put 800 in for Y and go 800 equals negative 1/3 P plus 4,000 over 3. And I'm going to use my calculator for most of this. I'm going to minus 4,000 over 3 from both sides. When I do this, on the left side, that 800 minus 4,000 over 3 I can't do. So 800 minus 4,000 over 3, math, enter, enter. I get negative 1,600 over 3 equals minus 1/3 P. And I'm just going to be lazy. I mean, I could do this all by hand if I care to, but I don't care to. So now I'm going to divide both sides by negative 1/3. On the right-hand side, I'll cancel the 1/3 and get a P. And on the left-hand side, I'm going to get 1,600. But I'm going to do that on my calculator. For the left-hand side, I'm going to go negative 1,600 divided by 3 for the numerator. And then divided by negative 1/3, which is negative 1 divided by 3. And that gives me 1,600 units will be, $1,600 is the price. So my question was, at what price will 800 units be rented? And my answer is going to be $1,600 will cost 800 units to be rented. I don't need to really write a sentence, but a dollar sign was nice there in the answer. Notice I did a lot of work on my calculator, and I kind of would expect you to do that unless you just care to do the fraction work by hand. It's kind of dangerous to do it by hand and probably safer on a calculator. Problem 4 was a linear regression problem. I never asked it on the test, so I just deleted it. I didn't really feel like doing it. I knew I wasn't going to ask it, and it's not that important. I can't think you're going to get it in another math class. You might get it in a stats class. So 5, 6, and 7 have a ton of parts, and the first part is find each function, describe the transformation from f of x equal to x squared, specifically state if the graph shifted left, right, up or down, and I should say narrower or wider, and if any reflection has occurred. So in part 5, or question 5, I want to find 2 times f of x plus 1 plus 3 when f of x is x squared. This is real easy to do. The 2 is going to go in front of a parentheses. The x plus 1 is going to go in a parentheses with an exponent of 2, and the plus 3 is going to go afterwards. And to describe what happens, the 2 is going to make it narrow. The plus 1 inside the parentheses is going to make it go left 1, and the plus 3 after is going to make it go up 3. I flashed something like this a bunch of times as we went through the chapter. So you should have this in your memory. If not at your memory, you should copy this down and have it at your fingertips and get it in your memory, or turn in your homework so you could use a note card. So this is done. This is part 5A. So this is the answer to 5A. Specifically, this and this are my answers for 5A. Now I'm going to make a table of values and sketch a graph. And when I go to graph this function for 5b, the function is 2 times x plus 1 squared plus 3. That's what I'm going to graph on my y equals. For my table of values, I'm going to put -1 in the middle of my x column. To get these graphs started, I set the inside of the parentheses equal to 0, and that tells me what number to plug in the middle of my x column for my table. And I'm going to get smaller and bigger. Using that set of x's with this in my y1 is going to make a perfect table to graph. So I'm going to turn my calculator on, hit the y equals. I just did a video for section 4.4. I need to clear the function that's in there out, and I need to shut my stat plot off by going second and y equals, hitting enter on the stat plot that says on. So now I'm going to hit enter, and I'm going to toggle over to off and hit enter. And now when I hit my y equals, the plot 1 that was darkened is not going to be dark anymore. Now I'm going to enter this function, 2 parentheses x plus 1 squared plus 3. I don't know, my window's way off. I need to make a zoom standard real quickly here. Let me go zoom standard. That's what the graph is going to look like. Let me get my table. So second table, next to -3 I see 11, next to -2 I see 5, next to -1 I see 3, and then 5 and 11. So I'm just going to plot those points, and that'll be my finishing up for part B. I didn't take the time to print out any graph paper, so it takes me a little bit longer here. And because of that, I'm not going to plot the points with the 11s because they're going to get too high for me to deal with. So I'm just going to plot these 3 points, and that's enough. 3 points, as long as one of them is a vertex and the other on either side of the vertex, are enough for a parabola. So I'm going to plot the point -2, 5, -1, 3, and 0, 5, and draw a U as opposed to a V through those points. So that's perfect for 5B. So done with 5B. Now I'm going to state the domain and the range for 5C. The domain for every parabola that we're going to graph is negative to positive infinity. So for 5C, there's no algebra to do for the domain. There's no thoughts. The domain for every parabola that we do is negative to positive infinity. And for the range, I needed to label the vertex. And I need that vertex. This vertex is the point -1, 3. -1, 3. To do the range, the vertex is at the bottom of the graph. The range is going to start at y equal to 3. And then the graph goes up to the top of the y-axis, which has a y coordinate of infinity. The range is going to end at y equal to infinity. So my range is going to be 3 to infinity. Square bracket on the 3 because it's an actual point on the graph. Part D wants me to state the intervals where the graph is increasing and decreasing. To do the intervals where the graph is increasing and decreasing, you put negative infinity on the far left edge of the x-axis, positive infinity on the far right of the edge of the x-axis, and the x-coordinate of the vertex, or the turning point, or the minimum point, also on the x-axis. And I create intervals with only round parentheses. I'm going to make an interval of negative infinity to -1, and an interval of -1 to infinity. So for part D, for the increasing and decreasing part of this, I'll look at the graph. The portion of the graph that corresponds to that interval is this half of the graph, and that's a decreasing because as I move from left to right, the graph is going lower. So that interval belongs with the word decreasing, or a down arrow. And the portion of the graph that corresponds to the -1 to the infinity is that, and that's an increasing interval. So that's going to go in my answer D. Done with part D. Part E asks me if the graph has a local maximum, and if it does, state the local maximum value. Because the vertex is at the bottom of the parabola, it doesn't have a local maximum, so I'm just going to say it has no local maximum, or I could just use the word none there. And part F, state if the function has a local minimum, and if it does, state the local minimum value. The vertex, because it's a low point, is a local minimum, so when I go to do part 5F, I can say there's a minimum x equal to 3 at x equal to negative 1, the x-coordinate of the vertex, and the minimum value is y equal to 3. There are wordier ways to write that, but as long as when you're talking about maximums and minimums, you give both the x and the y coordinate and attach some words that are similar to this, we're feeling good about our work. Alright, so I missed the break, so hopefully the little hiccup in the video doesn't mess you up. Moving on to 6, part A wants me to find the function compared to f of x equal to x squared. For 6a, the finding my function 1/2 times f of x plus 2 minus 4 should be easy to find. The 1/2 is going to be written first. The x plus 2 is going to be inside of parentheses with an exponent of 2, and the minus 4 is going to go after the function. To describe for 6a, because I found the function, now I'm going to describe the transformation. The 1/2 is going to make the graph wide. This plus 2 inside the parentheses is going to move it left 2, and that minus 4 is going to move it down 4. Now I'm going to do my table of values and sketch a graph. I need to do that on another sheet of paper. So for part B, I'm going to graph the function 1/2 f of x plus 2 minus 4, which is 1/2 x plus 2 squared minus 4. In the middle of my x column, if I set x plus 2 equal to 0, I get x equal to negative 2. I'm going to put negative 2 in the middle of my x column, and then go negative 3, negative 4, negative 1, 0. And now I'm going to enter the function. Put the 1/2 in a parentheses, so 1 divided by 2 in a parentheses, and then parentheses x plus 2 squared minus 4. If I hit graph, I'll see a picture. It's a wider parabola. And then second table, next to negative 4, I see negative 2. Next to negative 3, I see negative 3.5. And then negative 4, negative 3.5, and negative 2. I'm going to plot those points. And if you only want it to plot the easy points, that's enough. As long as you plot the vertex and 1 point on either side of the vertex, you don't need to plot all 5 points. So let me be lazy. And only plot the 3 points that I circled. It's going to be a completely adequate graph. So the first point I'm going to plot is negative 4, negative 2, and then negative 2, negative 4, which is the vertex. I'm supposed to label the vertex, so I'm actually writing the word vertex next to that point, and even writing the point down, and then 0, negative 2. So this is a wide-ish parabola. So that's perfect for 6b. 6c wants me to find the domain and the range. The domain of all our parabolas is negative to positive infinity. No thoughts there. And for the range, I'm going to put the y value of the vertex on the y-axis, which is negative 4. This graph goes to the top of the y-axis, which has a y-coordinate of infinity. I read from bottom to top. The range is going to be negative 4 to positive infinity. Part D wants me to find the intervals where the graph is increasing and decreasing. To do that, I put negative infinity on the far left edge of my x-axis, positive infinity on the far right edge. I take the x-coordinate of the turning point, or the minimum point, the vertex, and put it on my x-axis, and I create intervals with all round parentheses. So negative infinity to negative 2, and negative 2 to infinity are the intervals that are marked out by that. The first interval corresponds to this part of the graph, and that part of the graph is getting lower as I move from left to right, so that's going to be a decreasing interval. The next interval corresponds to this part of the graph, and this part of the graph is getting higher as I move from left to right, so that interval is going to go in my increasing answer. 6e wants me to state if the function has a maximum point. This vertex is a minimum point, so there's no maximum point or no local maximum. Part F wants me to state if the function has a local minimum and state the local minimum value. The vertex is a minimum point. When I go to answer part F, I'm going to say there's a minimum at x equal to -2, and the minimum value is y equal to -4. So when you're answering the part about the maximum or the minimum, you have to include both the x and the y coordinates in that answer. Alright, so that's everything for problem 6. Move on to problem 7. Part A of number 7, I'm supposed to find the function -f of x plus 8. So when I go to do part A, the function I'm starting with is f of x equals to x squared. I'm supposed to find -f of x plus 8. I'm not going to have a parentheses in this one because the x is the only thing in the parentheses in both versions, so I don't get a parentheses. The negative's going to go in front of the x, and the plus 8's going to go after. To describe the transformation, a -f of x moves the graph over the x-axis. The plus 8 is going to move the graph up 8. So to describe the transformation compared to f of x, it's going to be flipped upside down. So I'm going to say it reflects over the x-axis, and it's moved up 8. When I go to make my table of values, I don't have to put any thought into it. I'm going to have a 0 in the middle of my x column and have just standard table. So when I go to do part 7b, my table is going to have the numbers -2, -1, 0, 1, and 2. I'm going to put 0 in the middle of my x column when there's no parentheses in the problem. And now I'm going to enter this function and get my y's. So on y equals clear -x squared plus 8. And then I can graph it if I want to see what the graph looks like. And then second table, next to -2 I see 4. Next to -1 I see 7. Next to 0 I see 8. Next to 1 I see 7. And next to 2 I see 4. Now I'll graph all these points and be done with part B. So I need to get all the way up to 8. And my x-axis just needs to go between -2 and 2. So when I go to graph the points, it doesn't have to be a perfect graph. So -2, 4, -1, 7, 0, 8, which is the vertex. So I'm going to write 0, 8 is the vertex, because I was asked to label the vertex. And then 1 and 7 and 2 and 4, and then just make this something like that. That's a horrible graph, but it's good enough. Part C wants me to find the domain in the range. For all these parabolas, the domains are negative to positive infinity. And this range is going to be upside down because the graph is upside down. The bottom of the graph goes down to the bottom of the y-axis. The bottom of the y-axis is the y-coordinate of minus infinity. That needs to be the first number in my range, because for range, I read from bottom to top. The top of my range is going to be the y-coordinate of the vertex, which is at y equal to 8. So when I go to write my range, I shouldn't write 8 comma negative infinity. I should write negative infinity comma 8. The 8 gets a square bracket because it corresponds to a point on the graph. The negative infinity gets a round bracket because they all do. 7D is the increasing and decreasing, and usually I write arrows as opposed to the words increasing and decreasing. To do that, I put negative infinity on the far left edge of the x-axis, positive infinity on the far right edge of the x-axis, and the x-coordinate of the vertex 0 down there as well. Now I'm going to create intervals. The intervals that are going to be implied by this is negative infinity to 0 and 0 to infinity. Increasing and decreasing are all round intervals. The portion of the graph that corresponds to negative infinity to 0 is this one, and as I move from left to right, it's going up, so that's going to be in my increasing answer. This portion of the graph corresponds to 0 to infinity, and the graph is getting lower as I move from left to right, so that's a decreasing interval. 7F wants to identify any maximum, 7E wants me to identify a maximum point, and this vertex is a maximum point. So I'm going to say there's a maximum at x equals 0, and the maximum value is y equal to 8. Always when I go to answer the question about the maximums or minimum points, I separate the x's and the y's. And for part F, it's asking about a minimum point, and the function doesn't have a minimum point. So there's no minimum point, or no minimum would be fine. All right, so that's the end of 7b. 2 more graphs of parabolas to do. So that's 5 parabola graphs. That's way overkill. But these are the harder ones. These are the ones where I have to rewrite it before I can get started. So part A of number 8 wants me to use completing the square to rewrite the problem. To use completing the square to rewrite a problem, we separate the letters from the constant. There's a number in front of the x squared, we factor it out. If there's not, we add and subtract c. So completing the square involves adding and subtracting c to the letters and the numbers. C is always given by the template, some number divided by 2 squared, and that some number is a number in front of the first power of x term. So the c is going to be negative 4 over 2 squared, which is negative 2 squared, which is positive 4. So finishing up, I'm in the middle of 8a. Finishing up 8a, I'm going to get x squared minus 4x plus 4 plus 5 minus 4 by adding and subtracting c, replacing the c with the number. Now I'm going to factor these and combine these. When I factor those, it's a double minus. That's an x minus 2 times x minus 2. When I combine those, that's a plus 1. My answer for 8a is going to be m of x equals x minus 2 squared plus 1. So done with part A, I'm just going to say C below. For part B, to describe the transformation compared to an x squared graph, the minus 2 inside of parentheses is going to move the graph right 2. The plus 1 is going to move it up 1. Now I need to sketch a graph and make a table of values. The number that I'm going to put in the middle of my x column when I go to do part C, I set x minus 2 equal to 0 and get x equal to 2. So I'm going to put 2 in the middle of my x column and go smaller and bigger. And I'm going to enter this function and that function as y1 and y2 to make sure I get the exact same y's. I only have a correct answer is if I take the original function, x squared minus 4x plus 5, and the rewrite, x minus 2 squared plus 1, I only have a correct answer if when I hit graph, I only see one graph. If I see 2 graphs, I've made a mistake. And similarly, if when I hit second and table, I see duplicates in the y columns. And I see those duplicates and I only saw one graph, so let me get my table now. Next to 0, I'm going to put 5. Next to 1, I'm going to put 2. If your y's are different, you've made a mistake. Next to 2, I'm going to get 1. Next to 3, I'm going to get 2. And next to 4, I'm going to get 5. All I need to do is sketch a graph and label the vertex. I don't have to do any increasing, decreasing, maximum, minimum points. So I'm just going to graph these 5 points. and be done with 8c. So 0, 5, 1, 2, 2, 1, which is the vertex, 3, 2, and 4, 5. Just kind of draw them with a U as opposed to a V. A lot of times my graphs turn into more V's than U's. So that's everything for number 8. That's the easier version of the problems 8 and 9 that want me to use completing the square. Problem 9, when I go to do part A, I'm using completing the square to write it in standard form. So when I go to do 9a, I'm going to write this as h of x equals, and from these two terms, I'm going to factor out a negative 4. And I'm going to leave the minus 6 off to the side. And I'm going to write negative 4 parentheses x squared. And when I do take a negative 4 from that, I divide that by 4 and switch the sign and get minus 4x. So first step in using completing the square to rewrite a problem, if there's a number in front of the x squared, is to factor that number out. And this messes everything up when it comes to adding and subtracting c. So now I'm going to add and subtract c. Inside the parentheses, I add c. After the 6, I subtract c, and I take the number in front of the parentheses and put it in front of that c. So I'm going to get minus a minus 4c. So I'm going to rewrite this as h of x equals minus 4 times x squared minus 4x plus c minus 6, and then this double negative is going to make this plus 4c. Now I'm going to get a number for the c. My c always has the template, a number divided by 2 squared, and the number that I need to do that to is the number in front of the x to the first power term, which is that negative 4. So my c is going to be negative 4 over 2 squared, which is negative 2 squared, which is positive 4. Now into the problem, I'm going to plug my c in. I'm going to get h of x equals negative 4 times x squared minus 4x plus 4 minus 6 plus 4 times 4, putting in for both of the c's 4. I'm going to factor this and simplify this. So this is going to be h of x equals minus 4 times x minus 2 times x minus 2. That's what that factors into. This piece comes out to minus 6 plus 16. And for an answer to part A, I can say it's h of x equals minus 4 for that minus 4. That I'm going to write as x minus 2 squared. And this I'm going to write as a plus 10. To describe the transformation when I do part B, the negative is going to reflect it over the x-axis. The 4 is going to make it narrow. If it was like a half, it would make it wide. The minus 2 is going to move it right 2. And the plus 10 is going to move it up 10. Now I'm going to make my table of values and sketch a graph. Probably going to wind up only plotting 3 points, but maybe I'll get all 5. The number in the middle of my x column, I'm going to set x minus 2 equal to 0 and get x equal to 2. So 9c is sketching a graph. I'm going to put 2 in the middle of my x column. That's what I would get if I set x minus 2 equal to 0 and solve for x. Then I'll do 1, 0, 3, and 4. And I'm going to graph that and that function to make sure I haven't messed up. So let me clear these out. The original function, negative 4x squared plus 16x minus 6, I put in y1. My answer to part A, negative 4 times x minus 2 squared plus 10, I put in part B. When I hit graph, if I see 2 different parabolas, I've made a mistake. And when I hit my table, if I see different y's, I've made a mistake. But I have good things going on here. So next to 0, I see negative 6. Next to 1, I see positive 6. Next to 2, I see 10. Next to 3, I see 6. Next to 4, I see negative 6. Feeling lazy, so I'm only going to plot these points. It's enough just to plot the vertex and 1 point on either side of the vertex. And I'll do that just to save a bit of time. So 0, 1, 2, 3, and 4 go on the x-axis. And on my y-axis, because I'm only plotting the positive points, I'm not going to go down there and plot this point at -6. So I just need my y-axis to get up to 10. I'd like to not have to go up to 10, but the vertex is at 10, so I'm kind of stuck at doing that point. So plotting the point 1, 6, 2, 10, which is the vertex, and 3, 6. And then I make it just a parabola. Technically, it's supposed to go through the point 0, -6, so I kind of snuck that in. There's 9C. How many problems we have left? 1, 2, 3. Oh, there's only 3 problems left, so I'll squeeze it into this video, even though we're at 45 minutes already. So 10 gives me something out of section 4.4. Has a ball thrown up straight up into the air, and its height in feet after seconds is given by this equation. Question A is how long does it take for it to hit the ground? So this ball does something like this. It starts at 6 feet up in the air. If you put 0 in for t, you get 6. So it starts at 6 feet in the air. It goes up and it comes back down. And in this graph, the x-axis is the time in seconds. The y-axis is the height in feet. And I'm trying to find out when it hits the ground. When it hits the ground, the height is 0. I need to find the value of t that corresponds to the point that has a y of 0 for the height equal to 0. To do this, I'm just going to solve 0 equal to -16t squared plus 80t plus 6, and that's kind of horrible to solve. I'm going to use the quadratic equation to solve this. And I have a tough time doing the quadratic equation, so I'm going to be super patient. For my quadratic equation, which is -b plus or minus the square root of b squared minus 4ac all over 2a, I'm going to plug in for a, -16, for b, positive 80, and for c, positive 6. I'm going to go t equals fraction -b, which is -80, plus or minus the square root of b squared, which is 80 squared, and then minus 4ac, which is minus 4 times -16 times 6 over 2a, which is 2 times -16. I'm going to figure out what that equals to. Going to my main screen and doing 80 squared minus 4 times -16 times 6. That gives me 6784. And I'm going to do the square root of 6784. So second square root 6784. Oh, I get a horrible number. Oh well. I'm going to leave it square root of 6784. So I'm going to go minus 80 plus or minus the square root of 6784. And for the denominator, I'm going to put minus 32. Now I'm going to enter these on my calculators, and I'm going to have to round to 2 decimals because I'm going to get an ugly answer. So first work, I'm going to go parentheses for the numerator, parentheses for the 6784, parentheses for the numerator. So I'm going to have lots of parentheses. I'm going to go parentheses, and then -80, and then plus second square root. There's the first parentheses, 6784. I'm going to type 2 more parentheses, 1 to close out the square root, 1 to close out the numerator, then divide it by -32, and I get -0.07 seconds, which is a time that I'm going to ignore because that's a negative time and I only can consider positive times. Now I'm going to do the minus version of this by going parentheses, -80 minus second square root 6784, parentheses, parentheses, divided by -32, and I get 5.07 seconds. My answer is going to be 5.07 seconds because I've missed another hiccup, because it's the positive answer. The negative is this parabola goes back beyond the y-axis, and before the ball was thrown, it doesn't count. So this minus 0.07 is time that we don't need to consider. My answer to part A, it's going to be 5.07 seconds. For part B, it's asking the question when the ball reaches its maximum height. So the ball goes up, it comes back down. Its maximum height is going to be at the vertex. The x-coordinate of the vertex is the time where it gets the maximum height. And the y-coordinate of the vertex is the actual maximum height. Part B of this question really is just asking me to find the x-coordinate of the vertex. And I'm going to do that by using the negative b over 2a formula, where the b is the 80, so it's going to be negative 80, and the a is the negative 16. So the x-coordinate of the vertex is negative 80 over 2 times negative 16, which is negative 80 over negative 32. And I get negative 2.5 for that, and I'm going to leave that for my answer. So my answer for this is going to be at 2.5 seconds. And you could change that going math enter enter to 5/2 seconds if you care to. But I like 2.5 seconds. That's the time it's going to reach its maximum height. To get its maximum height, I'm going to plug in 2.5 for the t's. I'm going to go maximum height equals negative 16 times 2.5 squared plus 80 times 2.5 plus 6. And I'll just do that on my calculator. So clear negative 16 parentheses 2.5 squared plus 80 parentheses 2.5 plus 6. And the maximum height is going to be 199.6 feet. So that's everything for problem 10. Problem 11 is similar, but a little bit different. Gives me a similar function. It gives an object fired vertically into the air will be at a height h feet after t seconds. Gives me this formula. So this formula is going to graph similarly to the last formula. The object goes up and it comes back down, and the y-axis are the heights, the x-axis are the times. I'm supposed to find when the height is 80 feet. To do that, I'll mark out 80 on the y-axis for the height and go across to the graph. There's probably going to be 2 points on the graph that have a y-coordinate of 80. And the answer to part A are going to be the x-coordinates that correspond to those y-coordinates, because the x-coordinates are the times, the y-coordinates are the heights. I'm going to find the x-coordinates when the heights are 80 by solving 80 equal to minus 16t squared plus 96t. To do this, I'm going to set this equal to 0, and I'm going to get more positives than negatives by adding 16t squared and minus 96t from both sides. The equation I need to solve is 16t squared minus 96t plus 8 equal to 0. I can use a quadratic formula to solve that if I care to. If I'm clever, I realize that each one of the numbers is divisible by 16. This should be plus 80. And if I divide each of those numbers by 16, I'm going to get t squared minus 6t plus 5 equal to 0. If I divide by 16, I get the number small enough that I can solve by factoring. So if I'm doing part A, I'm going to be clever. I'm going to divide out the numerical common factor, and I'm going to get my answers by factoring. You could have, from right there, use the quadratic formula and get exactly the same answers. So I walk through the work without describing it. So I'm going to get an answer to part A for number 11. These are the two times where the object is at 80 feet. So my answer is going to be at 5 seconds and at 1 second. Part B, how long will it take the object to hit the ground? Again, I'm trying to find that point right there. That point has a height of 0, and I want to find the time where the height is 0 by just plugging in 0 for h and solving for t. So I'm going to get 0 equals negative 16t squared plus 96t. I don't like the 16, so I'm going to divide through by minus 16. This is going to give me, on the left-hand side, 0 divided by anything is 0, so I get 0. On the right-hand side, in front of the t squareds, the 16s cancel, and then 96 divided by negative 16 would be minus 6. So dividing through by negative 16 makes this a lot easier. This gives me 0 equals t squared minus 6t. I'm going to factor out a common factor of a t and get 0 equal to t times t minus 6. This will give me t equal to 0. T minus 6 equal to 0. This gives me t equal to 0 and t equal to 6. The t equal to 0 means this object started on the ground at time 0. It goes up and then it comes back down, and at 6 seconds it hits the ground again. So the answer to the question, how long will the object take to hit the ground? I'm going to say 6 seconds. The times are in seconds here. And the 6 is the number. To determine the maximum height occurs at the y-coordinate of the vertex. For the vertex, the x-coordinate is the time for the maximum height, and the y-coordinate's the actual maximum height. So I need to find the x-coordinate of the vertex before I can get the y-coordinate of the vertex. The x-coordinate of the vertex I get by using the formula negative b over 2a. The a is going to be negative 16. The b is going to be 96. So the x-coordinate of the vertex is going to be negative b, which will be negative 96, over 2a, which is 2 times negative 16. This is going to be negative 96 over negative 32. I think that comes out to be 3. In fact, I know it does. So at 3 seconds, it reaches its maximum height. To figure out what its maximum height is, I'm going to plug 3 in for those t's. I'm going to go h, which is that h, equals negative 16 times 3 squared plus 96 times 3. And this is going to give me the maximum height in feet. So to finish this problem up, I'm going to go negative 16 times 3 squared plus 96 times 3, and I'll get the maximum height, and that's the answer to this question, is 144 feet. This is a pretty grueling video, 46, yeah, we're just about an hour, but it's a pretty intense hour. Alright, last question. Problem 12, which is the last part of section 4.4. It gives me data about a baseball player hitting a ball. Basically, the ball goes up, it comes back down, and the graph is going to show x's that represent times, y's that represent the height of the baseball. And what I'm supposed to do first is make a scatter plot for the data. So to do a scatter plot for the data, I hit my stat button, hit enter on edit, clear out the lists that I have in there already, or delete all the numbers in the lists that I have in there already. And in the x column, or in the list 1, you put 1, 2, 4, and 5 for the times, which are my x's. In the y column, I do the heights, 5, 20, 25, and 5. Now I'm going to make a scatter plot to do part A. So second and stat plot, or second and y equals, hit enter, stir my stat plot on, and now do zoom stat. So now it's graphing the data. Oh, it's got that old problem that I need to get rid of. Let me go y equals, and clear these out of here. Now go back to the graph. So I'm going to see my calculator. Part B says using a graphing calculator, find a line and a parabola to fit the equations. So for part B, I'm going to come up and do linear regression by going stat, calc, number 4, linear regression, and then second and 1 for list 1, comma, second and 2 for list 2, vars, y-vars, enter on function, enter on y1, whoops, I forgot a comma, vars, y-vars, enter on function, enter on y1, and then enter. And it tells me the equation of the line is y equals 0.5x plus 12.25. It says the r is 0.08. This is only good if the r is bigger than 0.8. It's way too small. This is an acceptable answer for the equation of my line to fit the data. And I would probably change the y to an h because the y is the height. And I'd probably change the x to a t because the t stands for time. So both of these would be okay for my answer to part 12b for the linear function to fit the data, or the equation of the line to fit the data. The next thing I'm going to find is a quadratic function to fit the data, and I'm going to call that a parabola. And again, I can write y equals, or I can write h equals. So now on my calculator, I'm going to go stat, calc, go down to option 5 that says quadratic regression, hit enter, and then second and L1, comma, second and 2 for L2, comma, vars, y-vars, enter on function, down to y2 and hit enter, and then hit enter. And it tells me that the function is, I'm going to round to 2 decimals, is y equals negative 0.583x squared plus 35.5x minus 25.67. So that would be perfect for an equation for the parabola. It's a much better fit than the line because it has a 0.96 for the r squared. And my answer to part B for the parabola, I'd probably write h equals negative 5.83 t squared plus 35.5 t minus 25.67. But you can use either. So those are the possible answers for part B. Now when I hit graph, I'll see the data, the line, and the parabola. And the parabola is clearly a much better fit to the data. When I go to answer part C, which equation is a better fit, I'm going to say the parabola is the better fit. And then graph the function on my calculator. So I'm just going to say see my calculator. I'm going to delete the line by going y equals and just clearing the y1 so that my graph only has the data and the parabola graph because the line is not going to be useful for predictions. And then part E, find the maximum height of the ball. I'm going to do that by finding the vertex. To find the vertex, I hit second, calc, go down to maximum, trace to the left of the vertex, and hit enter. Then trace back to the right of the vertex and hit enter, and then get close to the vertex and hit enter. This is going to give me both the x and the y coordinate of the vertex. The x coordinate's the time where it reaches the maximum height, which is 3.04 seconds. The y coordinate's the maximum height of 28.34 feet. My answer to part E, the maximum height, is going to be 28.34 feet. This felt like a really long review, so I'm sorry that it felt so long. I probably kind of did overkill on the number of parabolas that I did. On the test, we won't get quite so many parabolas, and if I would have crunched the number of parabolas down, it would have shortened up the video quite a bit. All right, I'm going to stop the video now.